In this lesson, we are going to learn about behavior of current when it passes through a purely resistive, a purely inductive, and a purely capacitive circuit. Okay, so we are going to understand how your current behaves when you have a purely resistive circuit, or when you have a purely inductive circuit, or when you have a purely capacitive circuit. Okay, let's first look at a purely resistive circuit. Okay, so let's just say you have your AC voltage, okay, and you now apply a resistor across it. Okay, so let's just say this is R and this is V. Okay, we are going to assume V is given by Vm sine omega t. Okay, so obviously the current which flows in this circuit is simply going to be V upon R, okay, which is going to be equal to Vm upon R sine omega t, okay, which is going to be equal to, let's just say this is Im, so it is going to be Im sine omega t. Okay, so that's the expression for current in a purely resistive circuit. Okay, this guy you can write as Vm cos of omega t minus 90, right? This guy also you can write as Im cos of omega t minus 90. Okay, so basically if you want to draw phasors representing your current and voltage, you are going to have something like this. This is your complex plane. Okay, your voltage is going to be like this. Okay, this is your Vm at an angle minus 90 with respect to your real axis. Okay, this is minus 90, and your current is also at an angle minus 90, and it is having a length of Im. Okay, so your current would be like this. Okay, obviously your current is having a smaller magnitude as compared to your Vm. Okay, just see your Im is equal to Vm upon R. Okay, so your current is having a smaller magnitude as compared to your Vm. Okay, so this is the phasor diagram for current and voltage in purely resistive circuit. What you realize over here is, in a purely resistive circuit, your current and your voltage are in phase. Okay, both current and voltage have 0 degree phase difference and they are in phase. Okay, now let's see what is the power that is delivered in a purely resistive circuit. Okay, we know power is what? Power is simply voltage into time, or rather voltage into current. Okay, your voltage is Vm sine omega t, your current is Im sine omega t. Okay, so your power is simply Vm into Im sine square omega t, right? Just realize this is your instantaneous power. Okay, this is the power at a certain instant, at a given time t. Okay, that's the instantaneous power. Now if you were to draw the graph of power versus time, then you are going to get something like this. Okay, first let's draw the graph between your, this is my voltage, or this is my current, or this is my power. Okay, first I am going to draw a graph between my voltage and time. Okay, we know it is a sinusoidal graph. It's gonna be something like this.